Today on the bench we have a brand new President Lincoln 2 Plus. So this is, I guess, what you would call version 4. So this is the latest President Lincoln. Customer sent this in to see if I could do anything about trying to broaden up, or I guess you could probably more correctly say flatten out the transmit audio frequency response of this radio. He wants a loud talking radio. Well, people's terms during, different people use different terms. To me, when somebody says loud, they mean a splatter box. But this customer is going to, wants to have a good, clean sound. He's running a Heil microphone, so he's using good equipment. He just wants, but yeah, I'll have to tell you, brand new out of the box. Woo! Is this thing ever horrible? I have not taken the covers off of it yet. I haven't done, matter of fact, I haven't done anything to it other than to hook it up. Actually had played hell trying to get a damn signal generator hooked up to this thing, because this radio does not play with signal generators. So, I tried connecting BNC cable directly to one of my little test jigs I would normally use. One of my little switch jigs, so I can, switch the radios into transmit, but so I can inject audio. That's what the BNC's for. So, the center contact on that is hooked up to what would normally be the output of the microphone cartridge in a microphone. So that's the audio input. And if you try to hook up this BNC cable attached to that signal generator right there, yeah, it goes batshit. It will take the signal, but the problem is there's another continuous tone, some kind of feedback or something. Lord only knows. You run into this kind of thing occasionally, but no biggie. I just added some capacitive decoupling, so I simply stuck on a little BNC adapter here. That has a banana jack on the back side of it, and what I have, the audio then coming out of this adapter cable here, is just going through a 0.01 microfarad cap. So that's all I'm doing to feed the audio in. And adding that decoupling capacitor seems to have fixed the the radio not liking the signal generator. So get that down there. Okay, so what we want to check is what the frequency response is. So we're going to be using the signal generator up here. And man, this radio needs a lot of input too for peak power. Must have a really strong. I'm not sure, because I haven't taken it apart. I'm not sure because here's actually the factory microphone. I almost need to crack it open and see if it is a powered electret microphone. I'm pretty sure it's an electret, but I'm not sure if it's a powered type. And those style will actually have 1 or 2 FETs built into them, so some amplifiers actually built into the microphone cartridge. I kind of get the feeling it almost has to, because to get 100% modulation I had to put the output voltage at 150 millivolts. Now granted, going through a capacitor, but even still, that seems way excessive to me. But we shall try anyhow. So, I'm sweeping a frequency from 150 hertz up to 5,000 hertz. What do I have the time set to? 10 seconds. So it takes 10 seconds. I actually had to slow it down because I really want to see it, because it is so horrible. This thing is about as flat as a boomerang, or as flat as a circle. Because wow, it just the transmit audio frequency response on this thing is pitiful, to say the least. So if we look down at the spectrum analyzer, and you can look at the oscilloscope over there, you'll see the carrier and you'll see the frequency come up. It'll modulate and then it'll start to drop back down again. So I'm going to flip it into transmit. Signal generator, like I say, it's putting out 150 hertz to 5,000 kilohertz, and that frequency, it's sweeping through that frequency range every 10 seconds. And starting now. And that looks absolutely horrible. No other way to put it. So if you look down here, you can see, so each of these peaks, because we're in AM, each of these peaks are your sideband. So when you're in AM, you have a carrier right here, and then you'll have an upper and a lower sideband. We're looking at that peak right there. The other stuff, that's going to be distortion products and harmonics. But that big peak, okay, preferably you want it to stay at that level right there, straight out. You see how it's going down, 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 down. Now, granted, once you get up to 5,000 hertz, yeah, that's that's asking a lot of any radio. But you can see, even at 1,000 hertz, it's actually low. Because 1,000 hertz, each one of these lines, so here's the center, this would be 1,000, 2,000, 3,000, 4,000, 5,000 hertz. So if you look at it when it's at that point right there, you'll see it hasn't reached its peak yet. Comes up, it peaks, and it quickly drops back off almost 2,000 hertz. I mean, it's flat for, what, 500 hertz maybe, if you're lucky? It's peaked, and it's dropping off. Yeah, like 500 hertz worth of range. From like 1,500 to 2,000 hertz, it's flat. And let me just take it out of transmit. Spectrum analyzer went into calibrate. And it's not too hot. I wanted to feel the heat sink on the back of the radio. But yeah, and then if you look over at the oscilloscope, you can see it comes up and it starts to drop back down as quickly as it went up. Yeah, I mean, it's, wow. They really have a muffler stuck inside of this radio, because, man. So, going to have to see what we can do to try and undo that, because, man, that is about the, honestly, that's got to be one of the most pitiful frequency responses I've seen in a radio in a long time. I mean, that really is bad. And it seems like a nice radio. You know, like I said, I haven't done anything to it yet. Haven't even taken the covers off. But it seems to be a nice radio. Yeah, I'm not too thrilled with the channel selector. You can see how easily that turns. Of course, it's a rotary encoder. It's a modern radio microprocessor controlled. I'd like a little bit clunkier. I'm sure if you've ever watched any of my videos, that's one thing I always complain about, is the the channel selector switches. I mean, it's clicky, but yeah, it's not like, let me reach up here. Yeah, the Striker has more resistance. It's just not, yeah, I like a good clunk when I turn a channel selector. But got all kinds of modes. I mean, it's AM, sideband, FM, has CW, still has PA. Looks like, what do we got? Like I say, first time playing with one of these. Built-in echo, Roger beep, got an emergency channel. Actually, looks like it has maybe 2 emergency channels. Split frequency. This does have CTCSS and DCS tones, so, you know, it can be used for repeater if you're, you know, ham radio operator, for repeater use. Apparently it has Vox, so I guess, I don't know why in the hell you'd want Vox on a mobile radio, but whatever. 10kc switch, which another, again, I don't know why it has a 10kc button. At least in this mode, it doesn't skip channels, because you can, if you watch here, channel 19, there's actually 2 frequencies. There's 27.185, and there we go. You can see we're still on 19, 27.195. So what's the purpose of having, I don't know. Volume, RF power, squelch, memories, menu, channel. I guess that's if you prefer to use push buttons. They kind of seem hidden out of they're kind of trapped in there. There's tiny little buttons. Mic and RF gain, clarifier, does not have a detent, and I prefer that. I don't like clarifiers that have a detent. Yeah, they're handy for if you're doing an alignment, from my perspective, because clunk, I can lock it in. It's guaranteed that clarifier's on center. You do the alignment. The problem is, if you're a user, have you ever noticed when they have a detent, you always want to be, you go to turn it, the guy's clarified right there. As soon as you let go of it, it pops back down into that detent. So yeah, it's actually nice that it doesn't have the detent. So let me get the covers taken off of this monster. Of course, this is a surface mount radio, modern radio like anything else that's coming out of President. And of course, they're not making them. It's made by Kwai Zing Zing Zang, whatever the hell in the heck you want to pronounce it. That's who's making these things. It's the same company that's making those strikers right there. They're the same people making President's radios. Now that striker, I'll have to tell you, I was pleasantly surprised with that radio. Very impressed with the build quality. This one we shall see. Now this one is definitely a CB. That one up there, they really kind of tried. I get the feeling they were really pushing that one as a 10-meter radio, where this one they're pushing as a, that one they pushed as a 10-meter radio that does CB. This one they're pushing more as a CB that does 10 meters, if you know what I mean. So this one's definitely black box, what I call black box radio. It looks like a CB, it feels like a CB, it has controls like a CB. That one there, now of course that's AM, FM only radio, but that one definitely has more of the feel of a lot of the really small ham radios nowadays. It just happens to be able to be modified to do CB. Like I say, this one on the other hand, if it looks like a CB, smells like a CB, operates like a CB, yeah, it's just a CB that they call a 10-meter radio. So, let me get her cracked open. We'll see if we can get maybe some coils, some of the caps in the filter. They've got to have I'm hoping it's not some piece of junk op amp in there, like a dual op amp IC that's got a horrible frequency response. Hopefully it's, just they're doing some filtering with some capacitors and inductors to narrow up the audio, because, man, they definitely have some mufflers in there, because, man, that is restricted. So I shall return. Okay, so we're trying to flatten out the audio transmit frequency response on this President Lincoln 2 Plus, because I showed how fairly horrible it was, and they've got a lot of filtering in this thing. Probably one of the worst things they did was used a 4558 dual op amp. Let's see, it's this one right here. It's an NJM 4558. It's probably the one of the absolute worst dual op amps you can use for audio on the planet. A lot of radios use it. They're cheap. And anytime you open a piece of electronic equipment, because I've opened CD players and tape players, and if they have low fidelity, that's what you're going to see. They're going to have one of those 4558 dual op amps in there. Now in this radio, they're not so much. It's what's called an active low-pass filter. So you want some filtering, because you don't want everything getting through, especially any really high frequencies. You want to, knock off any RF that might be coming in, for starters. And you also do want to limit your bandwidth, because you don't want to be splattering all over the RF spectrum, and bleeding over into adjacent channels. But by the same token, we also do not want to be limiting the audio bandwidth on channel, which is what I showed this radio is actually doing. It's just horrible. I mean, it's rolled off at the front end, it peaks, and it's level or flat for about 500 hertz, and then it just rolls right back off. And it's that active low-pass filter that appears to be doing a lot of that. So they're using both sections, so it's actually a two-stage active low-pass filter. So basically, and what the op amp is doing is anytime you run a signal through a filter, it's going to attenuate the signal some, even the signal that you want. So, the frequency range we want to have, even it's going to be attenuated some. So the op amps are used to, the signal goes through basically a passive low-pass filter circuit, gets attenuated a little bit, goes through the op amp, it boosts it back up. It's a two-stage filter, and so basically it just repeats again. That signal comes out of one stage, goes into the other, the next stage, so it goes through another passive low-pass filter circuit, and then into the the other section of the dual op amp, gets amplified again, and goes on its merry way. And actually, after this is where it deviates and will be sent to either the FM, the sideband, or the AM circuit. So it's right after this op amp is where it gets, after that it's where it branches off into, depending on what mode you're in. So what I have here on the proto board is the passive component of that, which is what's actually doing the filtering. Like I say, that dual op amp really isn't doing any filtering. The only thing it's there for is as the signal gets attenuated a little bit, it's meant to just bring it back up. So, because you don't want to have a good signal going in, and by the time it gets through 2 stages of filtering, your signal's this big. So they're just re-amplifying it. So on the proto board here, I have that circuit set up. So all a simple passive low-pass filter is a resistor, little blue guy here, and a ceramic capacitor. And these are the actual values that they're using inside that radio right there. So it's a 220k ohm resistor and a 100 picofarad capacitor in series. So the signal, you have to remember this is an AC signal. So the signal basically comes in the resistor, comes out the capacitor, and then the capacitor goes back to ground, or the other side. The actual signal is injected at one side of the resistor, but the output is picked up right at the junction of the capacitor and that resistor. And then any of the frequencies that we don't want, that's what this capacitor is going to do. That's actually, basically attenuating down those higher frequencies, and they're basically shunted then back to ground. So I have, like I say, basically duplicated it. Now in this radio, they have 2 stages. So it would be this low-pass filter. The output would then go into the next stage of the low-pass filter. So basically what I'm going to show here would be 2 times as bad because this is only 1 stage of low-pass filtering. So I have the sweep generator set up again. The blue trace down here on the proto board is measuring at the input, okay? And then the yellow trace is actually the output. So we're measuring the input so you can see what's actually coming in from the signal generator. And then here at this red wire where I have I don't even really need the wire. I could just attach the probe directly to the lead of the resistor there. So I pull it out of the proto board. There we go. And you can see the blue trace. Like I say, that's basically a sample directly at the input. And then the yellow trace is the output of that filter network. And that's basically what you saw in transmit audio. It starts out and then it rolls off so horribly. I mean, look at that. It's just, yeah, it's attenuating the signal horribly. So if we take out this 100 picofarad capacitor, and we'll stick in approximately half of that, we'll put in a 47 picofarad, we can see nowhere close to as bad. Now we do want some attenuation. Once you get out towards the high end of that frequency range, you do want it to start rolling off. But you can see it's only rolling off about half, or actually less. And once we get up actually at that high frequency, you're getting to the point where it's an unusable audio frequency range anyhow. So actually that's about perfect right there. So I'll change out both of those capacitors in the 2 stages of that active low-pass filter. I'm going to take out those 100 picofarads and I'm going to stick in some 47 picofarads, and that should greatly help the transmit audio bandwidth, because yeah, as it is right now, it sucks. I mean, it doesn't sound too bad on air, but it's going to sound a lot better. It's actually kind of surprises me that the radio doesn't actually sound that bad on air, and it kind of surprises me as much because you saw on the scope, because what I showed initially on this thing, that was the output of the radio, a direct sample with the RF ports. You were looking at the modulation pattern, and you could initially see how much the modulation just went from 100% modulation to whoop, it just fell flat on its face. So yeah, I think that's definitely going to help that. It's going to keep a higher modulation level at the higher frequencies. So let me get those 2 little caps changed out. And of course they're tiny little ceramic surface mount caps. So I actually have to pull out the schematic here and take a look at them. But it's going to be two of the little small ceramic caps down in there, little surface mount caps. But we'll get those changed out and get her hooked back up, hook it up to the dummy load, and we'll take a RF sample and we'll see what it looks like on the spectrum analyzer and the scope after changing those out. Now I may actually tinker with some of the part of the negative feedback circuit in that active filter as well, because dual op amps have a positive and a negative it's 3 terminals: a positive, the negative inputs, and then the output. Not counting the power supply rails that go to your negative and positives, but they have a couple caps that run from the negative to the output. That's the negative feedback circuit, and that can also affect the gain at different frequencies. And I may play with those because I noticed, because this radio is basically the same as probably a dozen other radios, if not more. Quaising or however the hell you pronounce the company that actually makes these things, because it's not a President. This is basically like a Cree 8900, has a different PLL chip in it, but it is basically the same board that's used in the Cree 8900s, and has basically the exact same, well actually it does, it has the exact same design of active low-pass filter there, but they used some different values in that one in the negative feedback circuit. So, like I say, I want to play with those a little bit. I'll change out these 2 caps first, see what that does for my frequency response, and I might play with the negative feedback caps a little bit to see if I can get, because like I say, playing with those affects the gain of the op amps at different frequencies. So if we can, and we're starting to lose a little bit there, if I can then make up for that little bit where it's starting to roll off at the top end, where you can see it's starting to attenuate, the signal's starting to come down, if I can then make up for that in the gain of that op amp to re-amplify that frequency at the back end, basically, it should be fairly flat then. So let me do a little bit of tinkering and we'll see how it works. Okay, so I got those capacitors changed. I was happy. It did improve response, but yeah, it was rolling off still a little bit too fast right at the outside edge. It's still rolling off a little bit, but it was rolling off too fast for me. So I played with the capacitors and the negative feedback circuit of the dual op amp to try and boost the amplification once it got out towards what should be the top end of the higher frequency range. And I got that bumped back up now a little bit, and I think it looks pretty good. It's not ideal. For starters, like I say, it's a 450 or a 4558 dual op amp. I hate those things. They're just notorious for being crap when it comes to audio quality. They use them in everything. It's, of all the dual op amps made today, it's probably the worst one you could use for audio, and it's what everybody uses in low-quality components. If you get a high-quality stereo, yeah, that's the last thing they're going to use. But you're looking, like I say, cheap tape players, CD players, MP3 players. Yeah, a lot of times that's what you're going to see for one of the first or second stages of amplification, is one of those blasted things. And you can rest assured if you're, whatever gizmo happens to be, if it has crap audio quality, it's probably got one of those little things in it. But it's definitely better now. So same setup as initially. My little test fixture, my decoupling cap. Because like I say, this radio seems to be sensitive to hooking up test equipment. If I hook the output of the signal generator directly up there, yeah, I end up with basically like it'll sweep through the signal, but I also have another continuous toner yet, or some kind of feedback, and without getting too far into it, easiest thing is just a decoupling cap, and it works fine. But so that's the same exact setup that we had before, running up to the sweep signal generator, sweeping through the exact same frequency range, spectrum analyzer, and the oscilloscope over there. So if I put the radio into transmit now, see how that stays flatter, so much farther out than it did before. So we can see those peaks. Originally it would start out way down here, would come up, and then quickly drop right back off. We can see how we've kept that out to just about 4,500. Yeah, right, because that line right there, just let me sit here and look at it for a second and watch it. Yeah, so it's good. Even at 4500, it's only attenuated down 10 dB. So actually that doesn't look too bad. So, like I say, before it just quickly dropped off, and you can see it actually, there's a little hump in there. You can see it peaks, it drops down a tiny bit, goes back up, and then it starts to drop off out here at that outside edge. But so I'm sweeping the signal from 150 hertz to 5,000 hertz. That's what's coming out of that signal generator right there. And you can see, so each one of these, and the span of the spectrum analyzer, as before, is set up to 10 kilohertz. So, you know, your upper and your lower sideband. So each of these lines, vertical lines here, represents 1 kilohertz. So there's 1, 2, 3, 4, and then the edge of the screen is going to be 5 kilohertz. So you can see we're good. Flat pretty much almost 4,000 hertz, then it starts to attenuate and it starts to drop off a little bit, which is fine. Like I say, it's not drastic. It doesn't start to get drastic till you get probably around 4,500. So I'm happy with that. That's going to sound a lot better on air. It stays fairly flat, and same thing if you look at it over there on the scope. You can see it stays at 100% modulation a lot longer than it did before it really starts to, you know, shrink down as the modulation decreases, when it starts to roll off the really high-end frequencies. So, yeah, that's definitely looking a lot better. So I think the customer should be happy with that. Like I say, don't know, you can only get so much out of the circuitry that they have in this thing. But it's definitely a drastically noticeable improvement. So there you go. If you have one of these things, best thing to do is play around with the, like I say, the two-stage, get everything unplugged here, the two-stage active low-pass filter circuit that they have right there. Basically change the value, the values. The biggest change you're going to get is going to be the values you change for the passive component of that, those passive filter caps. But you can then fine-tune the negative feedback loop part of that, and that'll help to bring up the back end, because after I put those caps in, it was rolling off at around 3,500 maybe hertz, and like I say, I've moved that out to where it really starts to drastically drop off at about 4,500 hertz now. So between the reducing the value basically in half of the filter caps and increasing the value a little bit on some of those negative feedback caps, I was able to stretch out the frequency response a little bit farther. And like I say, that's a lot better than it was. Like I say, we had about 500 hertz worth of flat frequency response before, and we've got it's flat pretty much to 4,000, and then starts to really attenuate at about 4,500 hertz, which is perfect. So there you go. There's just if you have one, you want to play with it, that's the circuit you're going to be playing with, your dual low-pass active filter circuit right there.